Hi, you're welcome once again to my YouTube channel. If you're just joining for the first time, my name is Frances Onako, and this is a channel where we learn chemistry. Anything about chemistry, you get it here. Even if it has not been taught right in the previous videos, just know that it will still be taught. It's a channel where chemistry is broken down into simple terms so that you can easily understand it. And it's also a channel where we discuss real life issues, mostly inspirational and motivational stories, in order to inspire people and motivate them. If you're yet to subscribe, please do so. Hit that red button in front of you and press the notification bell beside it so that anytime I post new videos, you will get it. So today we're going to talk about relative atomic mass and relative molecular mass in chemistry. Have you heard of it? If you haven't, this is your time to learn it. And if you've heard of it and you've not understood it, this, I promise you, by the time I'm through with this lesson, by the time you're through with watching it, you would understand it. So let's get started.
Over the horizon, over the horizon.
Welcome back. So like I said, today we are going to discuss relative atomic mass and relative molecular mass. In chemistry, we have atoms and we have molecules, and for you to be able to differentiate them, molecules are a higher number of atoms, more than one atom. Okay, that's when you call it molecule. If it's only one, you call it an atom. If it becomes more than one, it becomes maybe 2 atoms, 3 atoms. You now call it molecules. So today we are going to discuss atoms and molecules in a higher way, in a more complicated and sophisticated way: relative atomic mass and relative molecular mass. So what is relative atomic mass? I mean, what do you mean by relative atomic mass? Now, scientists have done their research, and after everything, it has been verified and proven that the relative atomic mass of an element is the number of times the average mass of that element is heavier than 1/12 the mass of carbon-12. I will repeat it again. The number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon-12. Carbon-12 has been verified and proven that it can be used as the standard for defining the relative atomic mass and relative molecular mass. So, for example, now the relative atomic mass of nitrogen can be given as average mass of one atom of nitrogen divided by 1/12 the mass of one atom of carbon-12. When you divide that, you now get the relative atomic mass of nitrogen or any other substance. Just divide it. Average mass of one atom of that substance divided by the 1/12 the mass of one atom of carbon-12. Now, an instrument has been found and proven accurately. Chemistry, before anything is written down as a proof, as a theory, it must have been verified and proven to be accurate. So mass spectrometer has passed that test to be found to be the most accurate instrument for measuring the relative atomic mass of elements. It also measures isotopes, molecules, and compounds. Usually the most accurate instrument for measuring such. And a pure substance will give you 1 unit for the molar mass of a substance. That's a pure substance. If it gives you more than 1 unit, then you know it's not a pure substance. A pure substance will only give you 1 unit of the molar mass of that substance. Then we come to atomic mass units, popularly called AMU. There's also something called atomic mass unit. It is sometimes used where 1 AMU is an amount of matter that has a mass of 1/12 that of carbon 12. Okay, is an amount of matter that has a mass 1/12 that of carbon 12. That is what 1 AMU is. So from this definition, you can say that one carbon atom has a mass of 12 AMU, one hydrogen atom has a mass of 1 AMU, one nitrogen atom has a mass of 23 AMU, 7 AMU, 7 AMU for nitrogen. One oxygen has a mass and a mass of 16 AMU from that definition. So if they ask you what is the AMU of oxygen, you say 16. Okay, and the rest. Then we move to that. So that's all for relative atomic mass. Remember, any question you have, don't forget to ask in the comment section, and be assured your questions will be thoroughly answered. The relative, and also always try to visit the definition, the descriptive box, because you might get some important information there which you're not able to grasp while listening. The relative molecular mass. We move to relative molecular mass. This is just the same as relative atomic mass. The only difference is that where there is atom, it now becomes molecule. Just like I told you, they are basically the same, except that one is a higher number of the other. So for relative molecular mass, this is defined as the relative molecular mass of an element or compound is the number of times the average mass of that molecule is heavier than 1/12 the mass of one atom of carbon 12. I will say it again so you don't get confused. The number of times the average mass of one molecule of that element or compound is heavier than 1/12 the mass of one atom of carbon 12. Okay, its relative molecular mass of an element, like I told you, is the sum of the relative atomic masses of all the atoms in one molecule of a substance. You can also call it formula mass, except only that formula mass is used in a broader perspective, whereas the relative molecular mass refers only to molecules. Formula mass refers to molecules, ions, radicals, electrons, and etc. Okay, so to calculate the relative molecular mass, okay, some examples are given on the board on how to calculate the relative molecular masses of limestone, which is carbon triisocarbonate 4, and washing soda, which is sodium triisocarbonate 4. So let's look at the board to see how it is calculated. So and we are now in the practical aspect, which is calculating the relative molecular mass of some compounds. For example, limestone, which is calcium triisocarbonate 4. This is the molecular mass of limestone. This is molecular mass. This is the name, and then this is the name, the chemical name. This is the molecular mass or formula mass. Now, to calculate it, they've already given you some clues. They gave you their molecular masses. In chemistry, to calculate relative molecular mass, they must give you the mass. The atomic mass of each of the elements. So the atomic mass of calcium is 40, that of carbon is 12, and oxygen is 16. So let's solve it. First of all, we have one atom of calcium. So one atom of calcium is 40. Okay, we have one atom of carbon. One atom of carbon is 12. Then we have 3 atoms of oxygen. So 3 atoms of oxygen is 16 times 3, which gives us what? 48. So we now add them up. Bring this 40 here. We bring this 12 here, and then we add. 2 plus 8 is 0, carry 1, 1 plus 4, 5 plus 1, 6 plus 1, 10. So what it means is that the relative molecular mass of limestone is 100 gram. Okay? 100 gram. That is for limestone. Now we do another example. The relative molecular mass of another substance. Let us try the relative molecular mass of washing soda. Washing soda. Okay. Okay, so let's get to it. Washing soda is sodium triisocarbonate 4. This is the molecular mass for washing soda, and they have given us their masses, their atomic masses. Sodium is 53, carbon is 12, oxygen is 16. So let us get to business. So for sodium, we have 2 atoms of sodium. So 2 atoms of sodium will give us 53 times 2, which is what? 46. We have 1 atom of carbon. 1 atom of carbon will give us what? 12. We have 3 atoms of oxygen. 3 atoms of oxygen will give us what? 16 times 3, which will give us what? 48. We now add them up. 6 plus 2 is what? 8. 8 plus 8, 16. Write 6 and you carry 1. 1 plus 4, 5. Plus 1, 6 plus 4, 10. So the relative molecular mass of washing soda is 106 gram. Okay, so that's the practical aspect of it. If you have any question on it, if you can always ask in the comment section. Okay, so you've seen how we calculated the relative molecular masses of limestone and washing soda. That is how to calculate them. So with that, we've come to the end of this lesson. Remember to subscribe if you haven't done so, and hit the notification bell. Okay, and once again, if you're confused anywhere or have any questions, go to the comment section and write it down. Try to visit the description box, because I always put down some important information there. So thanks so much for watching, and till we meet again, it's goodbye.